नमस्कार, आप सभी का स्वागत है कृषि परीक्षा यूट्यूब चैनल पर। साथियों, आज हम जिस लेक्चर की बात करने जा रहे हैं, जिस सब्जेक्ट की बात करने जा रहे हैं, मोस्टली स्टूडेंट इसमें डिफ़िकल्टी फेस करते हैं। ये एक ऐसा सब्जेक्ट है जो कि एग्ज़ाम में मार्क्स स्कोरिंग है, इसके साथ-साथ ये डिफ़िकल्ट भी है। तो आज हम एग्ज़ामिनर जो पूछता है, उन्हीं चीज़ों की बात करेंगे, उन्हीं बातों के ऊपर फोकस करेंगे। तो एग्रीकल्चरल स्टैटिस्टिक्स के इस चैप्टर की शुरुआत करते हैं। चलिए, सबसे पहले हमको पता होना चाहिए कि स्टैटिस्टिक होता है क्या है। यहाँ पर हम डिफरेंट डिफरेंट फैक्ट्स, डाटा, उनके एनालिसिस, उनके इंटरप्रिटेशंस, उनकी समराइजेशन, उनकी क्लासिफिकेशन की बात करते हैं। तो सिंपली हमसे यहाँ से कोई डेफिनेशन नहीं पूछी जाएगी। जहाँ से क्वेश्चंस पूछे जाएंगे, मैं उन चीज़ों की बात करूँगा। जब कोई भी डाटा हो, उसका डाटा का जब समराइजेशन किया जाता है, उसे कहते हैं क्लासिफिकेशन। एंड क्लासिफिकेशन किसी कॉमन फीचर के ऊपर बेस होता है। जो क्लासिफिकेशन है वो आपकी जो भी किसी भी चीज़ के अंदर, जैसे आप टेबुलेशन कर रहे हैं, ओके, किसी भी चीज़ का एनालिसिस कर रहे हैं, तो उसको ईज कर देता है, आसान बना देता है। तो हम बात करते हैं कि क्वेश्चंस एग्जामिनर कहाँ से पूछता है। ये जितने भी पॉइंट हैं, ये ऑलरेडी किसी न किसी एग्ज़ाम में पूछे गए हैं। सबसे पहले चलते हैं पहले पॉइंट के ऊपर। फर्स्ट पॉइंट जो कह रहा है कि द वर्ड स्टैटिस्टिक किसने कॉइन किया था। दैट द साइंटिस्ट रिटन हियर गॉटफ्राइड इसेनवॉल। ये इंपॉर्टेंट पॉइंट है, इसको नोट डाउन कीजिएगा, ठीक है। देन फादर ऑफ स्टैटिस्टिक आर ए फिशर, आप सभी को पता होगा। इसके साथ साथ जब इंडियन कॉन्टेक्स्ट के अंदर बात की जाएगी तो पीसी महलोनोबिस इसके फादर कहलाते हैं। ये तीनों ही पॉइंट एग्जाम के अंदर पूछे गए हैं, जो कि आपके एग्जाम पर्सपेक्टिव से इंपॉर्टेंट हो जाते हैं। इसके बाद इंडियन एग्रीकल्चर स्टैटिस्टिक रिसर्च इंस्टीट्यूट, जो कि 1930 के अंदर सेटअप हुआ था एंड 1978 के अंदर इसको रीनेम कर दिया गया। कब किया गया था इसको? 1978 के अंदर। इस बात को आपको ध्यान देना है। तो ये कुछ बातें थी जहाँ से एग्जामिनर इसके ब्रीफ ओवरव्यू से जो क्वेश्चंस पूछता है। इसके बाद हमने बोला कि जो स्टैटिस्टिक है, इसमें डाटा का एनालिसिस होता है। तो जो डाटा है वो दो टाइप का होता है। देयर आर टू टाइप्स ऑफ डाटा, दैट इज वन इज द प्राइमरी डाटा एंड अनदर इज सेकेंडरी डाटा। व्हाट काइंड ऑफ क्वेश्चन एन एग्जामिनर आस्क फ्रॉम हियर? सपोज फर्स्टली तो वो आपको यहाँ से उसके डेफिनेशन के बारे में पूछ ले जाएगा। तो प्राइमरी डाटा क्या होता है? द डाटा कलेक्टेड फ्रॉम द प्राइमरी सोर्सेज। प्राइमरी सोर्सेज मीन्स जहाँ से वो डाटा ओरिजिनेट हुआ है। ओके, लाइक यू आर कलेक्टिंग सम डाटा फ्रॉम द इंटरव्यू, सम सर्वे। आपने कहीं इंटरव्यू से कलेक्ट किया है, सर्वे किया है, एक्सपेरिमेंट परफॉर्म किया है, तो वो जो डाटा कलेक्ट हुआ है दैट इज कॉल्ड प्राइमरी डाटा। ओके। एंड सेकेंडरी डाटा क्या होता है? द डाटा दैट इज ऑलरेडी इन द एग्जिस्टिंग फॉर्म्स, एंड जो ऑलरेडी पब्लिश हो चुका हो, उस डाटा को कहते हैं हम सेकेंडरी डाटा। देयर आर टू टाइप्स ऑफ क्वेश्चंस आर फॉर्म फ्रॉम हियर, द क्वेश्चन नंबर 1 and question number 2. First about their definition, and second about his he or she will give you, the examiner will give you four option. In among four option, three option is given from like primary data and one option will be given from the secondary data, like libraries हो गया, ओके, न्यूज़पेपर्स हो गए, या आपकी जो पब्लिश डाटा होगी, या कोई भी इन्वेंट्री होगी जहाँ पर वो डाटा ऑलरेडी कलेक्ट है। ओके, तो वहाँ से कोई ऑप्शन दे दिया जाएगा और तीन ऑप्शन यहाँ से दे दिए जाएंगे। तो आपसे पूछेगा कि विच वन इज नॉट द पार्ट ऑफ सेकेंडरी डाटा। ओके, तो लाइब्रेरीज, बुक्स, ये जो डाटा है दैट इज कलेक्टेड फ्रॉम समवेयर, तो उसे कहते हैं सेकेंडरी डाटा। वेरिएबल्स, द टाइप्स ऑफ वेरिएबल्स क्वेश्चंस आस्क फ्रॉम हियर, लाइक कंटिन्यूस वेरिएबल्स that can take any numerical value, whether it is in the fractional form, whether it is in the decimal form. So what kind of questions he will ask? For the definition of the continuous variables, but he will not ask the continuous variable definition, but supposedly he will give you some variables like 5 to 10, either it is 11 to 15, then again it is 10 to 15. So, so here the 5 to 10, where the lower limit and that of the upper limit is in the same class. Okay, जहाँ पर अपर लिमिट और लोअर लिमिट जब दोनों ही सेम क्लास के अंदर हो, दैट इज कंटिन्यूस वेरिएबल. व्हेन डिस्क्रीट वेरिएबल्स that can take only the integer form. Okay, that can take only the integer form, like for example number of nuts per bunch, number of leaves per tree, number of insect per hills, and supposedly we call it as a discrete variables. So we only take here integer value. Okay, there is two type of classifications methods. One is the exclusive method and another is inclusive method. I already talk about classification, summarization of data. Okay, summarization of data is known as classification. Classification mainly based on some common features, and one more common questions an examiner asks from you, that what is the first step in the tabulation. The first step in the tabulation is the classification. Okay, so there are like inclusive method and the exclusive method, and many of times the examiner asks question from here. Exclusive method, here the upper limit that is included into the next class, but in the inclusive method both upper limit and lower limit, both the lower limit and the upper limit included in the same class, that is inclusive method. So suppose you are having given some forms of data, some integers are given to you, and he will ask you which is the part of inclusive method. Okay, so inclusive method both lower and upper limit in the same class, like suppose 5 into 10, 11 into 15. So these both upper and lower limit are is in the same class. So suppose an examiner will ask about you about the width of the class, so you will find it very easily. Just a common formula, that is upper limit minus lower limit, and you can easily find the inclusive method width. But in the exclusive method, where that is upper limit is included in the next class, so suppose what is the easy way you can do that calculation, that is upper limit minus lower limit and minus 1. This is the formula for the exclusive method. See, this is the 2 points, the both lower and upper limit included in the inclusive method, but in the exclusive method, the upper limit will included in the next class. Now, I already talk about various variables and types of data. Okay, so next is graph. There are three types of graphs, like one dimensional, there are two dimensional and three dimensional. The examiner will ask you about firstly which is the one dimensional graph. So here are given some example like bar diagram, line graph and the polygraph. Then two dimensional, that is histogram and pie diagram. Then three dimensional, the cube, the cylinder and spherical. You have to be understand about like which is the part of one dimensional and which is the part of two dimensional. Now go on the second kind of question. In the second form of question, the examiner will ask, suppose in the given exam in the Odisha, he is giving some graph like this, and he asks about which kind of graph is this. So your answer should be histogram. Okay, what typically an histogram denote? It represent frequency, like these heights These heights represent frequency, and these frequency are in the continuous form, means this is the continuous data, because here is no gap. Whenever you talk about bar diagram, in the bar diagram, this is the this is the categories of data. Okay, and here is gap between them, clear cut gap between them. Whenever you find gap between them, you should put the option the bar diagram. But when the data is in continuous form and it represent frequency, okay, then you should put the histogram. You should put the option histogram. Okay, because in the bar diagram, the discrete data, I already talk about discrete data where only we take numerical form, only integer form. We cannot take decimal, we cannot take fractional form, only the integer form of data. Okay, because the bars do not touch. Then again the comes the pie chart. The pie chart is given here. Suppose data is divided into some forms. It represent part of the whole. It means this part is 20%, this part is 30%, this part is 10%. It represent the part of the whole. Okay, then supposedly in the histogram we talk about quantitative data. What is mean by quantitative classification? The classification that defines the qualities or categories, like what kind of eye color is this person is literate or illiterate. And quantitative classification that talk about numerical aspects, the height of that person, the weight of that bunch. Okay, these are the quantitative classifications. This is completed here our the classification of data, the bar diagrams, and other forms of data. So there are, I can summarize it in the fast forward mode. We have given three scientists here, one who coined the term in the Indian context and the father of statistics. Okay, and I talk about one institute, IASRI. I talk about when it is established and what is the time period when it renamed. One of the prestigious publications in the agricultural statistics is launched by the Ministry of Agriculture and Department of Statistics. I also talk about types of data. When in the statistic, we summarize the data, we analyze the data, we interpret the data. So kind of data. There are two types of data. That is, one is primary data and another it is secondary data. The primary data, the data that is our original work. Okay. Suppose we conduct some survey, we perform some experiment, and whatever data collected from there, it is primary data. The data that is pre-existing in the forms, that is pre-designed experiments, that supposedly comes under secondary data, that is stored in the libraries, that is stored in the books, that is already published data. Okay, so we already talk about like bar diagram, histogram, the pie diagram, where the histogram is used, where the bar diagram is used, where that is pie chart is used. Okay, now comes on central tendency. Central tendency. Suppose this data is spread here in the form, in the scattered form. This is randomly distributed. Suppose this point. Let me change the color. Suppose this point denotes the average. Means this typically single value denotes the complete mass of that scattered the random molecules. This is central tendency, means average. The kind of question an examiner asks from the central tendency, suppose he is giving some like the average is two types. One is mathematical average and another is positional average. The mathematical average, arithmetic mean, the geometric mean, which is harmonic means, and quadratic means. The positional means mode and median. So you should know about these are the part of central tendency. The examiner will give you some four options. In the three option, he put options from central tendency like arithmetic mean, mode, median, and one option range. And he will ask you which is not the measure of central tendency. So you put the tick, you mark the range because range is the part of measure of dispersion. So this is the first type of question, and mostly the examiner is asked. The same question is asked in the Uttarakhand WO exam. Now, suppose firstly the arithmetic mean. It is the simplest average. What we will do here, it is there is various values like sum of observation x, sum of observation x2, and sum of observation x3, and this way xn, and total number of observation. It means the second question you should know about its definition means the value arrived by dividing the sum of observations by the total number of observation. Here the term sum of observations like 2, 4, 6. Firstly we will do sum here. 6 plus 4 means to 12, and number of observation is 3. What is arithmetic mean? It is 4. Okay, so here the summation is the sum of data. Okay, and number of observation, and this is the formula of arithmetic mean, and it is asked many of times in the exam in the same form. The definition is asked in the RPCW exam. Now it is affected by change in both origin and scale. The origin is denoted by plus and minus, means addition and subtraction. The scale denotes the multiplication and division. Okay, this multiplication and division. Suppose there is average is x and that quantity is a. Whenever we add some value a plus x, this average will also be added x by x. Okay, so same in the scale whenever this is original average and this is the new average. Whenever some new things are added, the average becomes the new things. Okay, so it is affected by both change in origin and scale. Suppose I am taking 2, 4 and 6 and I am adding 3 in all of these. So here is 5, here is 7, here is 9. The sum here is 6 plus 4, 12 divided by 3. So here is the arithmetic mean is 4. Here 9 into 7, 16, 16 into 5, 21 divided by 3. It comes here 7 or 1. Okay, so here is the average is 7, here is average is 3. What kind of number we add in the 2 is 3. So in the average the 4 plus 3 that comes new average, that is 7. This is denote origin. Now what is scale? Now suppose you are giving some number 2, you are giving number some 4, you are number giving 6. The average is here 4. Now you are multiplying this 2 by 3. 6, 4 by 3, 12, 6 by 3, 18. Now add these all. This is 30, 36, and 36 divided by 3. Here comes 12. Okay. Now what value we are adding here? The 3 value is adding. We are not adding here. We are we are multiplying here. Multiplication is change in the scale. So change in the scale, we are multiplying by 3. So suppose this is original average and the new average is 4 into 3, that is 12. I hope you understand this thing. Now it is affected by extreme values and least affected by the sampling fluctuation. It is affected by extreme values. It means that data will be skewed. Either it is positively skewed, either it is will be negatively skewed. When the more data, like suppose 2, 4, 6 and 100, this is extreme value, and this shift the average, the central value, it is in the right side, and this is known as positively skewed. Now another example, 2, 4, 6 and minus 50. Here this time the central average will shift to left side, and this is known as negatively skewed data. Negative skewed data means that is pull away. Pull away means किससे दूर जाना. It is going far from that of the average. Okay. Now another questions that is comes from geometric means. We already discussed about arithmetic means. Arithmetic means like we can use weighted, pure height. Okay, these are examples of arithmetic mean. So there are three types of questions mostly asked from the arithmetic means. Means it is very simple form of average. One about their definition, one about their formula, and some examples. Next is geometric mean. In geometric means the data x1, then data x2, and then data x3, and its nth form. This is known as geometric mean. In geometric means when only two data is given, like suppose 1 upon may 16, 4 upon may 25. This question is asked in the recently conducted exam. In the two variables, this is very simple example, a into b. This is the formula of geometric mean. A here is 1 by 16 and b here is 4 into 25. Their under root, here we will do like 1 by 4 and 2 by 25, and this value comes 2 by 20, and when you divide, the result is 0.1. The 0.1 is the geometric mean. Now we will go on the 3-digit number. This is 3-digit number. First we have to be make product of all those things. 8 into 10 into 1, the product is 80. Now count number of observation. Number of observation is 3, and there is nth root, that is 1 by 3 is 0.33, and its nth root of 80 is putting here, and some value will come, that is your answer. This is how the geometric mean will be calculated. Now comes on the harmonic mean. In harmonic means, this is the number of observations. 1 by x1 is the observation 1, 1 by x2 is the number of observation 2, and in the x3 it is the observation number 3. You are putting some value like observation 0 to 4, here the value is 3, and 1 by x is 1 by 1. Okay, 1 by 4 or 1 by 4, 1 by 1 it's 1, 1 by 4 it's 0.25, and it is 0.25, and total is 1.0, it is 1.5. Okay, it is 1.5, and number of observation is 3, so a decimal above shift, it is comes 2. This is how that harmonic mean is calculated here. So the examiner will ask about the calculation also, and you should know about their formula, both the geometric means, both the arithmetic means and also the arithmetic means and the geometric means and harmonic means. Let me summarize this formula. For the arithmetic mean, it is summation of all data, means sum of all data divided by n. In the geometric mean, it is the product of all the observations and their nth root. And here in the harmonic mean, this is n 1 by x1 plus my 1 by x2 and 1 by x3. These values never be computed, never be used when data given is negative. Okay, it is meaningful only when data is positive. And one more point is written here, that is geometric mean become 0 if any variate in the series is 0. In the geometric means, we are doing the product of these variables. Whenever we multiply anything from 0, that whole thing will become 0. So this point denotes this kind of explanation. Now, mode. Mode means most frequently, the number with having the maximum frequency. Here the value 6 having the maximum frequency, so mode is 6. And the median, it is the middlemost value. Okay, uh, some data is given here 35472. Okay, okay, firstly you have to be arranged these data in the ascending order: 2, 3, 4, 5 and 7. The middlemost value is 4, and this is the median. This is for odd observation. When the even observation is given, like suppose this is the even observation is given, and you will take 3 and 4, these two number, sum of these two number is 7 and divided by number of observation 2, that is 3.5 is the median. And one more point is given here, the 50 percentile. This 50 percentile and second quartile, these represent an median. Okay, the 50 percentile and that is second quartile, that represent the median. This is how we completed the arithmetic mean, the geometric mean, the harmonic mean, mode and median. The median that is used, see, this median is used for like data that is skewed, means that is pulled away. Okay, and the method that is used here is OGIVE method, and data should be qualitative data, means intelligence, like emotions. When we talk about intelligence, we talk about emotions, we use as a average median. Okay, and mode by the histogram. These questions already asked in different exams. This is some relationships where the clearly we can get to know the arithmetic mean is greater than that is harmonic mean. Whenever some application, some calculation is coming on that geometric mean, like geometric mean, and data is given of arithmetic mean, so arithmetic mean into harmonic means and their under root gives us geometric mean. These are like when data is very symmetrical. When data is symmetrical, so mean equals to mode equals to median. When data is not symmetrical, some moderate asymmetrical, so mean minus mode equals to 3 mean minus median. This is the form, this is the formula for calculating that data. When asymmetrical distribution, where skewed distribution is there, the mode will find 3 median minus 2 mean. Let me calculate this by some calculation here. If the median of the series is 25, means 3 into 25 minus 2 into 30, here is 75, here is 60, and the mode is 15. Okay, I hope you understand. Let me do one calculation from the arithmetic mean so that you can catch that concept very easily. I make you habituate about this formula of arithmetic mean. So the mean of 11 number, the 11 it is here is 7. So firstly the sum comes here is 77, that is ex, the value is 77. Now the examiner questions are कि the one of the number 13 is deleted, so 17 minus 13 that is left 64, and now find the mean. So we have sum is 64 and now it's 10, or new number will comes, new average come is 6.4. Measure of dispersion, and it denote scatterness, it denote variability. Okay, how it is useful in your studies. Suppose there are two varieties are given, one having the yield 40 quintal, 42 quintal, 41, 44 and 45, and their mean yield is 42.4. And second variety there is 60, 40, 50, 30, 27, and having the same yield 42.4. This is the average yield. But see here the fluctuation is very much. This variety is not stable when we compare their yield. It is not a stable variety when we are comparing their yield. So we prefer variety 1. Now when we calculate the measure of dispersion, very most and very basic questions come from this measure of dispersion. You are giving four options. In the three option he will give another thing, and one option will ask what is the example of measure of dispersion. So you should know about what things that comes under measure of dispersion. One is the absolute measure of dispersion and another it relative measure of dispersion. Absolute it is range, that is quartile deviation, that is mean deviation. Okay, this is range, this is quartile deviation, this is mean deviation. So range is the simplest form. दिस पॉइंट नोट डाउन कीजिए, क्योंकि ये क्वेश्चन पूछा गया है कि विच मेथड ऑफ which measure of dispersion is the simplest one. Here is the range. We cannot include all observations here in the range. We only include that is largest value. We only include that is smallest value, the largest value minus that is smallest value. uh, this is range. Again is the quartile deviation. Quartile deviation you should understand and you habituate about this formula only, and that's it, that is sufficient for your exam. Now mean deviation. In the mean deviation you should know about it, about its formula, because formula is very much important. This is some individual unit, this is some average, and n is the observation. Okay, number of items. This completely denotes the deviations from the arithmetic means. Okay, this average either it is mean, either it is median. We can find out the deviations from the mean also, we can also find out the deviation from the median also, but the deviation is least in the median, and deviation is the maximum when we calculated, when we use mean. I will do this calculation also in the further slides. Now the standard deviations, one question is asked about is who given the concept of standard deviation, that is called Pearson. And this is the best line, the best most, this is the I already like discussed, the simplest measure of dispersion is the range. Okay, and most widely and most stable form is, that is your what we call it, standard deviation. Okay, its value range from 0 to infinity, And one simple question asked from here in the recently conducted exam, if some constant value is added to each observation, the standard deviation will remain unaffected, unaltered. Okay, जब कोई भी कांस्टेंट वैल्यू स्टैंडर्ड डेविएशन के अंदर ऐड की जाती है, दैट विल रिमेन अनअल्टर्ड, अनअफेक्टेड. This is the formula of standard deviation and asked in various exams. So this is the way, this is the deviation upon me and its square. Okay, so we can calculate, we can understand it through a calculation. This is the integers are given 4, 7, 8, 9. Firstly we will find their mean, because in the formula xi is the individual value. Okay, that individual value, but that x is average. So we have to find this deviation, and we will do their square and their root also. Okay, firstly we will find their mean. Mean is very easy. We will suppose like 7 plus 4 11, 11 plus 9 20, and 8 is 28, and number of observation is 4, so average it's 7. Now find the deviation. 4 minus 7, 7 minus 7, 8 minus 7, and 9 minus 7. This is the deviations. And suppose now we will do their squares. The value becomes like 3, 0, okay, and 1 and 2. Okay, when we do their square, 3 will becomes 9, 1 will becomes 1, 2 will becomes 4. The total it will be 14. Now this 14 divided by 4, it comes 3.5, and their root, and the value comes is 8.7. And one more thing is about variance. What is a variance? It is asked in various exams. Variance is the square of standard deviation. You only know about this much, then examiner will ask in your exam. Now relative measure of dispersion, that is correlation, coefficient of correlation. Okay, that is a unitless measure of dispersion that is given by the Carl Pearson, and its formula is standard deviation upon my arithmetic mean. I'll multiply by 100. This is simple form of the coefficient of correlation. And I will find some problems. Suppose one problem is given here, and it is the, like one point is given here. Wait, see this point. Let me do it, like prove it through one calculation. See, this is some problem is given, some value is given. Mean is here is 24, and the median is here is value 6, because median is the middlemost value. So let me find some deviation. When 24 minus 2, it's 22. 24 minus 4 is 20. 24 minus 6 is 16, and there is 76. And when we'll do their average, it comes 30.4. Okay, when we find the deviation from the median, like 6 minus 2, it's 4. Okay, like 6 minus 4 is 2, 6 minus 6 is to 0, 6 minus 8 it is minus 2, and 6 minus 100 it is 94. When we'll find out their average, here comes 20.4. So this point clearly depict, when deviation is calculated from mean, it is maximum. When it is calculated through median, it is least. And one another problem is given, that is constant. You will understand it, and you can comment this calculation. Okay, next is correlation. Correlation denotes the degree of association. Correlation may be positive correlation, it will be negative correlation. Positive correlation, if both the values move in the same direction. Okay, suppose height is increased, it will definitely increase its weight. Negative correlation, suppose a company's profit will decline when the number of claims is increased. These two these two variables will move in opposite direction. One more term that is perfect will add in between them. Suppose perfect positive correlation, perfect negative correlation, it is only when the change sorry when the changes are in the fixed proportion. Okay, if there is no relation, there is no correlation, there is two variables are interdependent. Okay, this is interdependent, this is there is no relationship, and this diagram is known as scatter diagram. Correlation can be found through the Karl Pearson coefficient of correlation and scatter diagram. Okay, now when the value is r equals to plus 1, it is perfectly positively correlated. Okay, so it is from left to right, and all the point is in on the same line, it is stick on the line only. Okay, this is only line only, only line only, and this is more from like left to right, left to right. This denote r positive, perfect positive correlation. R negative when the scatter diagram is in this form, from right to left. Okay, all point on the line only. This is perfect negative correlations. When r equals to 0, it is scattered randomly, there is no related or interdependent variables. The correlation coefficient denotes the strength, denotes the direction between two variables. It is unitless measure. Okay, it is unitless measure. Okay, its value lies very important question, minus 1, 2 plus 1, and that is regression, uh, minus infinity to plus infinity. Correlation coefficient unaffected by the change in origin and scale, but regression coefficient only dependent to change of origin, but it is affected by change in scale. These 2 points you should know. Okay, I already talk about origin and scale. Okay, the Karl Pearson coefficient of correlation is not appropriate when relationship is non-linear, because this correlation Karl Pearson coefficient applicable only linearly data, linear data, that is continuous data. Correlation coefficient through regression are bxy dot byx. These two variable y on x, the effect of x on the y, effect of y on the x, and their under root. So this is the relationship you are giving, like if bx is greater than 1, then byx definitely less than 1. If any one of the two variables is positive, another one will be positive. If any one of the negative, another will be negative. The positive तभी होगा जब दोनों के दोनों वेरिएबल पॉजिटिव होंगे. This is the summary of this all those things. If r equals to 0, the line of regression perpendicular to each other. Very important point. When r plus positive, r equals to plus minus 1, this means the two lines, two variables will coincide at intersect at the right angle or parallel. Okay, they are intersect at right angle or they are parallel. Suppose very important formula is given for finding that Karl Pearson coefficient of correlation. Very important formula. Covariance between x and y under root of x and under root of y. Okay, this is how. Covariance between x and y is 5. That is variance of x, that is 4 and 9. Here comes 5. 2 into 3, that is 5 upon 6, 0.83. This is how you will find the Karl Pearson coefficient of correlation. Now, here comes experimental design. From moving towards the experimental design is a preset performa where treatments are applied. So, what is treatment? Treatments are something like object of comparison. Suppose yield, suppose fertilizers, means like factors like spacing of plant, date of sowing, breeds, these oftenly known as treatment. Okay, experimental error, some deviations, some biasness, that is experimental error. Now, in experimental design that is given here, there are three basic principles and you should know about their definition. One, replication, one, randomization, and local control. Replication means execution of experiment more than once. The execution of experiment more than once. Local control, the homogeneity means maintain the homogeneity, means within the block. That's why it is known as blocking. This is known as blocking. One very important questions asked from here from CRD, I will discuss is in the later slides. These principles are given by R.E. Fisher. Okay, randomization means all the treatments are randomly distributed. Okay, so here 3 points are given. The grouping of the homogeneous experiment units into blocks is known as local control of error. Again, point second, that to reduce the experimental error, to reduce the experimental error, to reduce the experimental error, the principle of replication, the local controls are used. Okay, to valid estimate of experimental error, that is experimental error, to validate that estimate, you will do replication and randomization. To reduce the experimental error, you should perform the replication and local control. And one very important concept, that is uniformity trial, that is soil fertility gradient. Okay, suppose this is the plot, you divide this plot in this way, in small plots. Applied all the treatments, applied all the treatments without any biasness. Okay, and check their fertility gradient. Okay, check their yield. Suppose the yield is 51 here, 20 here, and 42 here, 50 here. The fertility gradient will be this direction. We will talk about this is in this slide. We having the CRD, we having the RBD, we having the LSD. CRD is performed in the lab condition, RBD is performed in the field condition. Very most important point asked in many exams. CRD, the field is homogeneous, so local control is not performed. Okay, लो कोई भी लोकल कंट्रोल यहाँ पर परफॉर्म नहीं किया जाता है. देर इज नो लोकल कंट्रोल. होमोजीनियस होने की वजह से तो आपसे यही पूछा जाएगा कि लोकल कंट्रोल का परफॉर्म नहीं किया जाता है. द लोकल कंट्रोल इज नॉट परफॉर्म्ड इन द CRD. Material heterogeneous. ANOVA, one way classification, two way and three way. Soil fertility, very important point. One direction, two direction. Error degree of freedom. In CRD, you have the maximum freedom. Okay, and minimum freedom is the LST, Latin square design. In LST, here one treatment is applied in the row, one treatment is applied in the column. Okay, okay, this is the row, this is column. So one treatment is applied here in the row and one treatment is applied in the LST. So LST having like superiority over that of the CRD or RBD. Okay, यहाँ पर जो ईच ट्रीटमेंट है, ईच ट्रीटमेंट applied in the one row, one column. Okay, now this is degree of freedom. Many questions asked from this point. You should know about their formulas and we'll do some calculation from this formula. Number of treatment is maximum here 220 to say 24 and here is 5 to 12. Suppose, and let me do one thing. One, you have split plot design. In split plot design you having two plot, one is major plot, one is subplot. This is for the larger plot, this is the larger plot for a big treatment. Like suppose you are having irrigation applied somewhere, you are showing some variety, so you will put here, it is for providing maximum space. In the sub plot, it is for precision. Okay, this is for precision, this is for area, it means large area. Okay, split plot design, this is split design. Here two plots are there. Okay, the treatments are one that is main plot, another is subplot. And one more common question asked from here, error. The error is maximum in the main plot and less in the subplot. This equation you should know about it. And subplot where the precision is higher, in the main plot where area is higher. Okay, so here is given the plot, main plot that is large size means to accumulate the treatment which is large in size, and the that is your subplot that is for the precision. Error you will find here. And one question is given here, suppose you are giving 4 sowing date, 5 varieties and 3 replication. So it will easily you can find the total degree of freedom by 4 into 5 into 3. Suppose it is 520. Okay, multiply by 3 minus 1. Okay, so this is the formula. So 4 into 5 into 3, 5 into 3 15 into 4 here is 60. Okay, minus 1, that freedom is 59. This is your answer. The degree of freedom is mostly asked in the chi-square test to find the fitness, goodness of fitness, goodness of fittest. Okay, so there is formula of degree of finding the column 1 minus row 1. Okay, so the 4 minus 1 and 3 minus 1, this is 3 into 2, the value is 6. This is how the degree of freedom will find out. And I will take one more example in the RBD, because in RBD degree of freedom is asked many of times. Suppose you are giving a replication 4 treatment you are giving 3, then you will do 4 minus 1, multiply by 3 minus 1, here 3, here 2, that degree of freedom is 6. This is how you can find out the degree of freedom. This is the complete overview. This is the complete chapter from an exam where an examiner is asked certain questions. I hope it will be helpful for you all. Thank you. Jai Hind, Jai Bharat.